Hello, can you hear me? My name is David Knezevic. I'm a co-founder and the CTO of Akselos. We make engineering simulation software, in particular cloud-based engineering simulation software. So as some of you may know, when engineers design anything these days pretty much, they simulate it first. So if they're designing bridges, buildings, planes, cars, whatever, a huge amount of effort goes upfront into simulation for virtual prototyping purposes. And the key technology for engineering simulations is called finite element analysis. You may have heard that term if you're an engineer. And so what Akselos does is we make accelerated finite element analysis software. The technology is based on over 10 years of research at MIT. I was in a research group there with my co-founders. And really what we're trying to do is to unlock the potential, unlock the value of simulation software, because as we see it, simulation tools are too cumbersome, too slow for many engineers around the world to use. Simulation is already a very successful multi-billion-dollar industry, and we think there's a huge amount more value that can be unlocked through more new algorithms that really allow engineers to simulate things much faster with much less effort. So that's what this first slide here is just pointing out. Our simulation software based on new algorithms, MIT allows you to perform simulations up to 1,000 times faster than with the conventional approach. It allows you to do very large simulations. It allows you to simulate fully three-dimensional complex models. And I'll give you a demo shortly. Just a little bit of background about the technology. As I mentioned, it comes from MIT over the last decade, and it's been funded by the Department of Defense because obviously DoD has identified a similar need to perform large-scale simulations with much less effort. Okay? And just to briefly indicate, these are the three verticals we're currently focusing on: mining, oil and gas, and power generation equipment. And let me just, I've only got 3 minutes left of the demo part, so let me just dive straight into actual demos so you can see exactly what I'm talking about. So what I have here actually is a large-scale piece of, it's a simulation of a large-scale piece of mining equipment. Okay, so what do we do here? This is our graphical user interface. You can actually download it yourselves and try it out for free at www.akselos.com. We have trial versions available for anybody who's interested in this kind of thing. And what we do is we decompose a large simulation into what we call simulation components. Okay, and that enables you to run a simulation like this, which would normally take over a day if you try to do this with conventional FVA simulation software. We're able to do this 1,000 times faster, so on the order of seconds or minutes, which makes a huge difference to the productivity of engineers who need to use this kind of software on a daily basis. I pre-solved the simulation. Yeah, I'm not going to try to do it over the Wi-Fi in this sense. It's a bit fogged up at the moment, but you can see here, this is the result of a full three-dimensional simulation of this piece of equipment. It takes about a minute to run with our cloud-based software. You press the solve button. It's hosted on Google Compute Engine. The solution is computed there, and it gets downloaded here. I did that just before, and that's the result. And one of the interesting things about software is that it's component-based. So building a model like this is really like playing Legos. So when I say we want to unlock the value of simulation software, part of what we're doing is allowing engineers who are not experts with simulation technology to perform complicated simulations like what you see here. So for example, I can click on part of it and I can just delete it. I can reconfigure this thing, I can add cracks, I can add corrosion, I can add damage, and perform all these kinds of complicated simulations in much more quickly than would have previously been possible. Another thing we're doing is we're involved with edX. You might have heard of edX. So edX is a MOOC, okay? And we're providing cloud-based software for a course called 2.01X, which is MIT's Structural Engineering 101 course. Here's a cloud-based app running in a web browser that students in this class use. And it enables them to, instead of just solving math problems, doing integrals and stuff like that, they're able to do fully three-dimensional simulations like what you see here. This is a WebGL app, I'm rotating this kind of thing. You change parameters and resolve, and you're able to do all these kinds of complicated simulations just running in your browser. You don't have to install anything. Okay? And I've got here just a the discussion board for 2.01x, and here's some students talking about our software. Thanks so much for providing this app. It allows us to visualize these kinds of complicated things in ways we could never do before. Okay, so I'm out of time. Happy to take questions.
Yeah, so I presume that you actually can feed models from like PTC and SolidWorks and all that sort of stuff in this without modification, or do you actually have to use some sort of pre-programmed mesh that you have to that you provide? So is there any manipulation of the model you have to do to use this? I guess that's the first thing. I guess the other thing I want to say, it seems like you're sort of developing a company that's essentially an outsourcing model for finite element analysis for companies that now provide this capability in their systems. Is that correct? Okay, so two questions there. So the first part, how do you input a model into our system? So we can't directly import a model, like a standard CAD model, and expect it to run in our system, because our software uses a different principle. Okay, we use this divide and conquer approach, which is what gives you that 1,000 times speed up that you don't get with conventional simulations. That's because conventional simulations treat the large model as one monolithic thing. We decompose it into components. Okay, so what the model I showed before was a model that an engineer had sent to us. We decompose that up front, and then what we do is we store those components in a web library. And what you see here is a website. Again, Akselos.com. You can play with this stuff if you're interested. What we do is we have this large library with lots of different components. Okay, you can download the components, you stick them together in different ways, and you can perform simulations. So our vision is to have a very large database of simulation components. It's going to grow over time, and crowdsourcing will allow us to grow. So that you can substitute complicated 3D models very easily with this new approach. The second part was basically is your push to sort of outsource, provide an outsourced model for. Suppose I'm an engineer and I've purchased a simulation package with my SolidWorks thing. Is that, do you sort of see your company sort of stepping in and say, you don't have to purchase that, you can come directly to us and buy that service?
There's different approaches. At the moment, what we're doing is, I don't know if we're necessarily exclusively focused on outsourcing. I mean, basically, this is a simulation tool. People, at the moment, it's a SaaS-based simulation platform, basically. So we're interested in different ways of monetizing that. At the moment, basically, companies are using this for specific projects. They did very fast simulations. We make a customized set of components for them, and they use it. And also, basically, we've got this trial version that you can go and play with yourselves, and that's just going to be like a freemium model. We limit the size of the problem you can solve if you're just using the free version. If you need to do something bigger, you get in touch with us. But, of course, there's many ways to go about it, which we'll explore over time. Yes?
So how does this work on a mobile device?
Well, it can be used on a mobile device. So, actually, we think that one of the advantages of our approach is that it's component-based. So it really is compatible with a touch interface. And we would like to explore maybe a tablet, using a tablet to connect these components in the way I described. And, it's like playing with Lego blocks, as I said. So you can connect Lego blocks on your tablet. I think a smartphone screens are too small. You saw the model. It's still a very intricate three-dimensional thing that you're trying to deal with. So you don't want to be dealing with a tiny little screen. But I think a tablet is feasible. But also, you can see it running in a web browser. So really, there's two different things we're doing here. One is where you have complete freedom to play Legos, to make a large structure out of whatever components happen to be in our library of 10,000 components. The other thing is here is a fully defined model, and all you can do is change a few parameters. Okay? All you can do is change this maybe to change this from titanium to aluminum, and press solve and get the new answer.
But it's more than just view only, because I know a lot of the other products that are CAD-based, you can only view the models, you can't actually manipulate them on a mobile device. So it sounds like with this, you can actually do the calculations and move things around on a well, let's say a tablet.
Yeah, you can. Well, first of all, this is totally different from CAD. CAD is a three-dimensional picture of something. And this is simulation. This is when what are the stresses? If I load the structure in this way, what are the stresses? What are the forces here and there? That's a simulation. That's a structural simulation that we're doing, or other kinds of simulation. So CAD is more about building a three-dimensional model. This is about building physical simulation of a three-dimensional model. So it's very different from CAD. It's much more involved with FEA, as I mentioned, ANSYS, Abacus, these kinds of FEA software packages. But then also, of course, we can, But this is not just view only, this is doing a simulation. The heavy duty stuff is done on Google Compute Engine, and what you do here is just render the results. Okay, in your browser, on your smartphone, on your tablet, or on your computer, whatever.
Okay, I understand this.
Last question.
Does this fit into the pharmaceutical platform?
So the question is, does it fit into the pharmaceutical industry? Well, certainly those industries use a lot of simulations. To my understanding, they don't use simulations that are easily componentized. So that's one of the key aspects of what we do here. You can see that we decompose large models into smaller components, pre-compute stuff for those components, and reassemble them and do very fast simulation. So the type of geometries people deal with or whatever in the pharmaceutical industry are not so amenable to that. So it's not something we've explored as yet, but it could well be something we're looking to do down the road. Thank you.
Come join New England's largest technology meetup, sponsor an event, present, or attend. Visit www.bostonnewtech.org.